All right, today we're going to talk about evaluating functions, and we've actually already talked about this, but we're going to continue to build on some of the vocabulary that we're using and just some of the ideas that we've been talking about for the last week or two. So, all right, I want you to imagine this first example here. So, I want you to imagine you take your car to the mechanic, the person who works on your car, and they let you know that they have to replace your muffler. The muffler itself, the piece of equipment, is $200, and the mechanic charges $40 an hour for labor, which actually nowadays I feel like is a pretty reasonable price. A lot of places charge way more than that. They want you to create a function which models the cost of a repair job, where H, this is the number of hours the mechanic needs to finish the job. So really this is just asking you, hey, could you figure out mathematically how much this is going to cost? And so what we're going to say is we're going to say C of H. So C of H, this is a function, right? This is the name of the function right here. This is the input of the function, right? Remember that? We talked about that last week. So C is the name, and I think C is just for cost, right? H is number of hours. So the cost as a function of the number of hours is going to be $200, because that's how much the muffler itself is. That doesn't change. Plus, and then we're going to have to pay $40 for every hour that they're working. So I think it would make sense that we would take 40 and multiply it by H, because H is the number of hours. So I think 200 plus 40H would give us a reasonable number for, or a reasonable expression for how much it's going to cost overall. You could also say 40H plus 200, like if you want to switch these around, that's fine too. I think it makes sense to start with the 200, but the other way is not wrong. Okay, question. If the mechanic works for 3 hours, how much would the job cost? So if the mechanic works for 3 hours, so here's what we do. We say C, I got to put my highlighter away, C of 3. And so what we're going to do is we're going to take this function, and wherever we see an H, we're going to put a 3, because we would like to know if we input 3, what would the output be? And the output is the cost. The input is the number of hours. So C of 3 is equal to 200 plus 40 times H, where H is now specifically 3, because I want to know how much it's going to cost for 3 hours. So this would be 200 plus 120, right? 40 times 3 is 120. So that would be $320. So if they're going to plan on working on it for 3 hours, it'd be $320. Okay? If the mechanic works for 7 hours, how much would the job cost? So again, it's the same idea. We're going to do C of, except instead of 3 now, I would like to know if my input was 7, what would the output be? So this will be 200 plus 40 times 7 now. So that's 200 plus 280. So that'd be $480. And if your mechanic takes 7 hours to put in a muffler, I feel like that's not good. I don't think the repair job's that long. Okay, so what are we using as inputs for the function? So again, this is a function. It's kind of a machine of sorts that takes inputs and gives us outputs. So what are the inputs? Like, what are we putting into the function? It's the number of hours. Okay, so it's the number of hours, hashtag. Or if you're old like me, we call this the pound symbol. Yep. Okay, what are the outputs of the function? The output, when you plug in a number, what do you get as the output? You get some number of dollars. So that number of dollars is the cost of the repair. So the output is the cost of the repair. So this function is kind of cool. It's very useful and practical. It takes the number of hours that the mechanic is going to work, and then the output is it tells you how much the cost of the repair is going to be. So this is a really nice, useful function here. What would a reasonable domain be for this function? So remember, domain is a collection of all the inputs, right? So collection of all possible inputs. So the question here is, what numbers could we potentially plug into the function? Like, what numbers would be reasonable to put in for H here? Like, could the mechanic work on your car for 2,000 hours? No, that seems like really unreasonable. right? Could they work on it for zero point 0.1 hours? For a muffler fix, I think it's more than that, right? I think it takes more than 6 minutes to replace a muffler. So this is going to vary depending on your opinion. There's no like strong and fast answer here. But basically, I'm going to say I think any number between 0 and, I don't know, I'm just going to say like 10. I don't know, maybe mufflers take longer. I could look it up, but so I'm just going to throw out a ballpark answer of 0 to 10. So any number between 0 and 10 would be a reasonable input for this function. Okay? So remember, the domain is a collection of all the inputs. So we're saying, hey, I think these are all the reasonable number of hours your mechanic could work. What would be a reasonable range for this function? So the range is like the domain, except the domain is looking at inputs. The range wants to know what is a collection of all the possible outputs in this scenario. So I would say the lowest amount you could get charged would be $200. Although you can't replace a muffler with no time, so some people might put a parenthesis here, but whatever. And then what's the most that you could pay for this? Well, I guess if you worked for 10 hours, that would probably be good to find out, right? So $200 plus 40 times 10. And if you do that, that gives you $600 right there. So the output is the cost that you're going to incur by having the mechanic fix the car. And I think it would be reasonable to say that it's going to be somewhere between 200 to 10 hours of work, right? Because 10 hours was our upper end for our input over here. So that's going to be somewhere between $200 to $600. Okay? All right. So we're going to come up to a definition here. When you have a function and put specific numbers into it to figure out the specific output, this is called evaluating a function for a value. To evaluate a function for a value means that you substitute a number in for the input and figure out the resulting output. So that's what we just did, right? We came up here, and this right here is called evaluating the function for a given value. So we evaluated it for 3 and for 7 there. Okay, so that's what it means to evaluate a function, and we've already talked about that some. But okay, another example. So this is actually a true story. A friend of ours, we live in Westerville. They had their dog sprayed by a skunk, and they called the pest control company because the skunks are just like they run around everywhere, and especially in the spring. And the company that they called, they came out and they set up traps to try to like capture the skunks. And they told our friend that they would charge $130 to set up the traps. And then I thought this was kind of crazy. They were going to charge $60 for every skunk that they actually captured. So, yeah, so it's like, hey, it's for us to even come out and set up the traps, it's $130, and then it's $60 for every skunk that we end up catching. It's like, wow, okay. So f of x is going to denote the cost to capture x skunks. So they want us to write a function using function notation. So what we're going to say is we're going to say f of x is equal to, so this is the name of the function, right? F is the name, x is the inputs, and then the output is going to come over here, right? This is going to be the output right here. So what we're going to do is we're going to write something here with some numbers. We're going to put, some numbers in here, and that's going to help us figure out how much the cost is going to be based off of how many skunks they end up capturing. So what was the flat cost for this? So it was $130, right? So it's $130 just to set up the traps. Even if they catch no skunks, they're still going to charge you $130. And then it's $60 per skunk. So what we're going to do is we're going to do plus $60 times the number of skunks. So how many skunks are we capturing? Well, we don't know, but we're going to use a variable to kind of represent or hold the place of that number. So that's x is going to go right there. Okay, so this is your function, and this tells you right here in the yellow like what the cost is going to be based off of how many skunks you capture. So okay, so that's that. Part B, they want you to evaluate f of x, the function you just created here, when x is equal to 6 and explain what it means in the context. So what we're going to do is we're going to say f of 6. So f of 6 is equal to 130 plus 60 times 6. And we're going to plug in that 6 there. So we just literally replaced the x's with 6, right? See how I'm highlighting the x's in yellow here? So we took the x here and replaced it with a 6, and we took the x here and replaced it with a 6 there. So what would this be? This would be 130 plus 360. 60 times 6 is 360. So that would be a cost of $490. So they want you to explain what it means in the context. I'm going to ask you guys this question a lot, and I know you guys hate this question because this question requires you to truly understand what we're talking about here. So what we're saying here is if they catch 6 skunks, such a weird word, it will cost $490. It will cost $490. So that's what we're saying in this specific scenario, and that's what this means right here. So f of 6 means it's going to be $490 for us. Okay? All right. If the company is hoping to make $670, use the function from part A, right up there, to solve to figure out how many skunks they would need to capture to be able to charge $670. So remember, when you do this, this right here is the cost, and this right here is the cost. And we're saying the cost is equal to the cost. So what we're saying is if you take this and plug in a number for x, it's going to tell you the cost. But what you can do sometimes is you can say, hey, look, I know the cost is 130 plus 60 times x. So what you can do is you can say, all right, I know the cost is equal to 130 plus 6x. And then what you can do is you can say, hey, I want this yellow thing here to be $670. So what you do is you actually put the 670 over here on the left side because that's the cost, right? So you put the 670 there and you say that that's equal to 130 plus 6x. Okay, hopefully that kind of makes sense, because if this is the cost right here, you can actually say, hey, I want to know when that's equal to 670, and then you can work backwards and figure out what the x needs to be in this scenario. So this is the amazing power of algebra, is that it's no longer like a guess and check game or like where you have to do this step by step in your head. Like you can actually just write something out and use this to solve for x to figure out what x is. And once you get good at this doesn't really take a whole lot of thought. It's actually pretty straightforward and pretty easy. Okay? All right, so let's solve here. So I'm going to subtract 130 from both sides. So we get 540 is equal to 6x. And then what do we do from here? We divide by 6 on both sides. So we divide by 6, and we get that 90 is equal to, or not 90, sorry. Yes, that is 90. Why am I getting 90? Oh my gosh. It's not 6x, it's 60x. Oh my gosh. All right, so rewind. So I was like, they don't need to catch 90 skunks. That would be super expensive. So this should be 60x here. My apologies. All right, so 670 is equal to 130 plus 60x. And then we minus 130 from both sides. I was like really confused there for a sec. I was like, I'm pretty sure I did that right. So then when we divide by 60, not 6, divide by 60, you get that 9 is equal to x. So it would be 9 skunks is how much the company would need to catch in order to make $670. Okay? All right. What's a reasonable domain for this function? And then what's a reasonable range for this function? Again, so what is the domain? It's a collection of, if you consider every possible input that we could put into this function. So what are the inputs here? X is the input, so it's the number of skunks that they're going to catch. So I don't know. You kind of have to ask yourself, like, what's a reasonable number of skunks that they might catch, like in a single neighborhood? And your guess is as good as mine. I'm going to say it's probably somewhere between like 0 to 20, okay? I don't know how many skunks there are in a particular neighborhood. So let's just say 0 to 20. I don't know. So the domain, like a reasonable domain here would be 0 to 20. A reasonable range for this function would be whatever the outputs are when you put in those numbers, right? So like if you catch 0 skunks, it'd be $130, right? And then what if you caught the full 20? So like how much would that cost? So what we're going to do is we're just going to figure out how much it would cost to catch 20 and put that number right there. So All right, well, it's 130 plus 60 times x, where x is 20. So this would be 1330. So 1330. So the domain would be you're going to catch somewhere between 0 to 20 skunks, and the range is that you're going to pay somewhere between $130 to $1,330. That seems reasonable. Okay? All right, let's flip over to the back here. Example 3, a company is tracking their trucks and needs the computer to be able to quickly calculate how far a truck is from its destination based off how many hours it's been since the truck left. The truck is driving to Columbus, Ohio from St. Louis, Missouri, a distance of about 400 miles. The truck's average speed is about 60 miles per hour. So for part A, they want us to write a function that can calculate how many miles the truck still needs to travel as a function of how many hours have passed since it left St. Louis. And this is really crucial here. It's asking us to figure out how many miles a truck still needs to travel as a function of how many hours have passed since it left. So if it just left like 0 hours ago, how many miles would it still need to travel? It would still need to travel. Sometimes I make a table for this and it helps me visualize this. So this is h, this is d of h over here. So if we have traveled 0 hours, how far do we still have to go? We have to go 400 miles, right? Because you just left. If you're 1 hour in and you go 60 miles per hour, then you would do 400 minus 60. So you now have to go 340 miles. If you're 2 hours in, you now have to go 280 miles. If you're 3 hours in, you have to go 220 miles, and so on and so forth, right? You just keep subtracting 60 as you do this. But what I want you to see here is that this function, the outputs actually, notice how as the inputs are going up in number from 0 to 1, 1 to 2, those numbers are getting bigger. The output numbers are actually over here getting smaller. So it's kind of what we call an inverse relationship. Like as one number goes up, the other number actually goes down. So they're kind of opposite of each other. So the reason I bring that up is because our function here is going to actually need to go down as the h value gets bigger and bigger. So we just have to keep that in mind. So it's not going to be like 400 plus h or something like that. It's going to be, there's going to be some subtraction here is what I'm trying to say. So, all right, d of h is equal to, so again, we start at 400. So there's definitely going to be a 400 here. But now we just kind of need to figure out what we want to do with the 60 miles per hour and number of hours. So if we drove, okay, let's kind of think about this real quick here. If we drove 1 hour, how far would we still need to go? It'd be 400 minus that 60 miles that we already drove, right? So 400 minus 60, that would be 1 hour if we had been driving for 1 hour. What if we have driven for 2 hours? It'd be 400 minus 2 times 60. What if we had driven for 3 hours? It would be 400 minus 3 times 60. What if we had driven for 4 hours? It would be 400 minus 4 times 60. You're kind of starting to see the pattern here. However many hours we've driven, like that's the number that we put out in front of the 60, right? When it was 1 hour, it was just 1 times 60. When it was 2 hours, it was 2 times 60. When it was 3 hours, it was 3 times 60. When it was 4 hours, it was 4 times 60. So the amount of time we have to, or the amount of miles we still have to cover is going to be 400 minus the number of hours that we've already driven times 60. Okay, so it's going to be 400 minus, go ahead and look down here now, 400 minus the number of hours that we've driven times 60. So it's going to be 400 minus 60h. Okay, so this function here, its name is d. It takes h as an input, and then its output is d of h. Okay, just to use that little function thing from a few days ago. They want us to evaluate d of 5 and explain what it means in the context. So d of 5 would be 400 minus 60 times 5. Right? 400 minus 60 times 5. We're just substituting in a 5 where the h is there. So what does this mean in the so this would be 400 minus 300, so that'd be 100. That means after driving 5 hours, you still have, so what does this 100 mean here? This means that that's how many miles you still have to go if you've been driving for 5 hours. So you still have 100 miles to go. So that's what that means in the context. So after you've driven for 5 hours, you still have 100 miles to go. Okay? All right. Write an equation and solve to figure out how many hours it would take for the truck to arrive at the location in Columbus. So this is really crucial here. What does it mean to arrive at the location in Columbus? That means how many more miles do you have to go if you're at your destination? Right? Like if you're at your destination, how many more miles do you have to drive? 0, right? So what we're going to do is we're going to say, hey, this right here is a distance, this right here is a distance, and I want this thing right here to be 0. So what you'll do is you'll say 0 is equal to 400 minus 60h. And then you can solve from here. So if it was me, I would personally add 60h to both sides. So you get 60h is equal to 400. And then you can divide by 60 on both sides. So you get that h is equal to whatever 400 over 60 is. Let me throw that in the calculator real quick. 400 over 60 is 6.67 hours. Round that up there. Okay? So, and a lot of you are going to say, Mr. T, why don't we just take 400 and divide it by 60? Like, this is an easy problem. And I hear you. And yes, you could do that. But I want you guys to start to get comfortable with this idea of function notation and algebra and solving like this. Okay? All right. What's a reasonable domain for this function? So remember, the domain is number of hours that we've driven. So I'm going to say that the least number of hours you could drive is 0. It doesn't really make sense to drive negative number of hours. And then the most number of hours you could drive would be this 6.67, right? Because you can't drive more than that because you've already arrived. So let's say 6.67. That's the most number of hours you could drive. And then what would be a reasonable range for this function? So remember, the domain is the inputs and the range is the outputs. It's a collection of all the, not inputs, outputs. So the question comes up then, like, what would be a reasonable range for this scenario? So what were the outputs again? So if we go look at our function, what's the output? The output, this number over here, is a distance in miles right here, right? So that number is a distance. So how many miles could we possibly have left in our trip? So that the lowest number of miles that we could have left to drive is 0. What's the highest number of miles that we could still have left to drive on our trip? What if we haven't left yet? How far away are we? We're 400 miles away. Okay? All right. So for the sake of time, I'm going to go ahead and be done with our notes here.